everybody, welcome back. Algebra 2, Bradley Arita here. Today we're talking about factoring polynomials. We're going to be working on finding solutions to polynomials, and for us to be able to do that, we need to know how to factor them. Okay, so our learning target for today is that I can find zeros of polynomials using factoring. You can tell by my nice handwriting here what our learning target is. We're going to talk about three ways that you can do this today. The first two ways are going to be the most common. The third way, it's a little bit more rare, happens, so you need to be aware of it. But we're going to talk more extensively about the first two, which is factoring out the greatest common factor and then factoring by grouping. So I'm going to jump in right here and I'm going to show you what we're talking about. Factoring out the greatest common factor, this is always something you should attempt when you're trying to solve for a polynomial or trying to factor. You always want to try and take out a greatest common factor to make these pieces smaller, okay, because we have smaller components here, and so we can find solutions more easily. If you take a look here, we've got x to the third minus 4x squared minus 5x. And so something here we're going to look for, is there a constant or a variable that's common in all three of these terms? And in this case, there is. There is an x that is common between all three of these. So what we'll do is we take out an x. When I say take out, I mean we're dividing an x from this term. Okay? And so when we take out this term, when we divide the x, we were at x to the third. This now becomes x squared. Okay? This was negative 4x squared. We take out 1x. This now becomes negative 4x. That's a negative sign right there. And then this is negative 5x. This now becomes just negative 5 because we factored out the x. And we can see that here. If we were to multiply this x back into all of these terms, we would end up with where we started. Okay? Now, this first piece out here, well, that's good. That's separated out. We don't need to worry about that anymore because we can't break down x any further than it's already broken down. But we can break down now this guy right here, x squared minus 4x minus 5. We're going to go back to unit 3, and we're going to factor this even more. Okay? We're going to multiply our first term here and our last term. So this is a 1 and a negative 5. That's going to give us negative 5. And we're going to find two numbers that multiply to give us negative 5 that add to give us negative 4. Okay? So I'll make our factor, called T-chart here. Okay? We're looking for numbers that multiply to give us negative 5. Well, there's only two combinations. It's 1 and negative 5, and then negative 1 and 5. And if it can be factored down further, then one of these will add up to be negative 4 down here. We can see that this one, in fact, does. So 1 right here and a negative 5 right there. Those are our two factors. They'll multiply to give us negative 5, and they'll add to give us negative 4. We'll come back here to our problem, and we'll take this variable, and we'll substitute these values in to these parentheses, so it looks like this. Okay. So using the greatest common factor, we first removed an x from the equation to make it x squared minus 4x minus 5. Okay, we didn't just completely get rid of the x, we just set it over here to the side. And then we reduced this into two factors. I should say simplified it into two factors, which is x plus 1 and x minus 5. If we multiply all these three things back out, we would end up back where we were. Now for today, this is our answer. This is the extent. This is as far as we're going to go. In the next unit, we're going to be solving these, but we can't solve these very well until we know how to actually set up and factor these. Okay. Zoom in on this one right here. We've got 3y to the 5th minus 48y to the 3rd. And we're going to try and figure out what can be removed from both of these terms to make this smaller and more factorable. We see that they both have y's, so we know we can remove y's. And then 3 goes into 3, and 3 also goes into 48. So we can remove at least a 3. Okay? And then, let's see, 5y's and 3y's. We can remove 3y's from both of these terms. That's a 3. 3y's in both these terms. Okay? Well, if you take away the 3y's from the 5 right here, you're left with a 2. Okay, well, we're actually dividing that out. When I say take away, I don't mean subtract. I mean we're dividing it out here because we're removing the greatest common factor. And 48, we're going to also, okay, we're dividing by 3. That gives us 16. And that's it, because the y to the third has already been removed from it. So now we got y squared minus 16. Now when this happens, what we're noticing here is that there is a number here, right? This is a 1. We don't write it, but it exists. And what we notice here is that there is a 1 here, which is a perfect square, and there is a 16 here, which is a perfect square. And this is important for us to recognize because this is the difference of two squares. If you didn't recognize that, then you probably didn't already jump into factoring, and you could set it up like this, and right, first term times the last term is negative 16, and then they add to equal the middle term. Well, there is no middle term. That means that it went away at some point, so it had to equal 0 in order to be gone. So we're looking for two numbers that multiply to give us negative 16, that add to give us 0. Well, 4 and negative 4 would do that. Okay, 4 times negative 4 would give us negative 16. 4 plus a negative 4 would give us 0. So these are our two factors. What that means here is that this factors down. This is a positive 4, so we'll put a positive 4 there. And this is a negative 4, so we'll put a negative 4 right there. Okay. And so that's how we're going to factor these down. Okay. Again, we get into solving these next week, but for right now, this is the step you need to be able to do, is break it down into its smallest pieces so we can end up solving for this. Okay. I'll let you guys try C here. I'll jump back in just a moment and see how you did. Go ahead and pause this, try C, and then go ahead and come back and hit play when you're ready. All right, okay. Well, let's see what's got in common between all three of these terms here. We've got 5, 30, and 45. We have a 5 common in all those terms. And then z to the fourth, z to the third, and then z squared. We at least have z squared common in all of those terms. So we're going to divide everything here by 5z squared. Well, 5 divided by 5 would be 1. Z to the fourth divided by z to the second is still z to the second. I put that little line across my z's right there so you know it's a z and not a 2. 30 divided by 5 is 6. And this is z to the third divided by z squared. It just leaves us with 1z. And this is 45 divided by 5 is positive 9. Z squared divided by z squared is just 1. And so there we go. Okay. If you got to this part, fantastic. Hopefully you took the next step and then tried to factor this down further, which is take this first term, multiply it by the last term. Okay, it's 1 times 9 is 9. And then bring this guy down here. And now we're looking for two numbers that multiply to give us 9, and then add to give us 6. 3 and 3. Okay. That means our factors here would look like this. Z plus 3, and then z plus 3. If this was factored all the way down. 5z squared, z plus 3, z plus 3. Okay. So that's factoring out with the greatest common factor. Okay. Down here now we've got, factoring by grouping. And what's most evident as far as when you're going to be using this strategy is usually if there's 4 terms, you're probably going to be doing factoring by grouping. And here's how you do factoring by grouping. First of all, you're going to put these in standard form, right? You put the highest exponent over here on the left, and then each next exponent needs to be less than the one previous to it. It can skip some stuff, but it's going to be at least less. So this goes 3 to 2 to 1 to 0. So everything's good here. What we're going to do is we're going to group the first two together. Okay, we're going to put right after here, I'm going to put these brackets or these parentheses right there. And then this right here will be another one. And you'll notice I'm including the sign in front of this negative 4z because that negative sign actually belongs to the 4z. So I'm going to make sure to include it in that parentheses. Well, what I'm going to do is I'm going to remove the greatest common factor in each parenthesis. This is z to the third plus 5z squared. There's got to be something common between those two terms, and there is. There is a z squared that is common between those terms. Okay. What's left here is a z plus a 5. Okay. If we multiply that back out, we can see where it came from. Z times z squared would be z to the third. And then 5 times z squared would give us 5z squared. Then over here, we're going to factor out whatever is greatest between negative 4z and then negative 20. Since this is a negative right here, we're going to be factoring out a negative number. So we got 4 and 20. Well, negative 4 is going to go into negative 4, and negative 4 also goes into 20. So we'll factor out the negative there. That's going to leave us then with z here, and then negative 20 divided by negative 4 gives us positive 5. Okay. What we see here is this one and this one match. Okay. So that tells us that that is a factor. So one of our factors here is z plus 5. Okay. The other factor is made up of this guy and this guy, z squared minus 4. Okay, z squared minus 4. Z plus 5 can't be simplified any further, but z squared minus 4 can, because we recognize that this is called the difference of two squares. This is 1 right here. Okay, 1 times 1 will give us 1, and this is 4. That's a perfect square because 2 times 2 would give us 4. So this can actually be broken down further. Okay, we've got z plus 5 right here, and this can break down into z plus 2 and z minus 2. Okay. Again, this breaks down because we'll multiply the first and last number, which is 1 times negative 4. It's negative 4. And there's no middle term in here, and so that has to be a 0. So we're looking for two numbers that multiply to negative 4 that add to give us 0. And we've got negative 2 and positive 2, and that's negative 2 and positive 2. That's where those come from right there. Okay. Go ahead and try B here. Try B on your own, and then come back here. Go ahead and pause me, and then come back, and we'll see how well you did. Okay, welcome back. We're going to go ahead and solve this one, or excuse me, simplify this one. We're going to group here, group here. Okay. X to the third minus 2x squared, something in common between these two terms, and it's x squared. Okay. That leaves us with 1x in here and a negative 2. Okay. And then since this is a negative, we'll take out a negative here. 9 and 18, we need the largest number that goes into both of those. The largest number that goes into 9 and 18 is 9. Right. Well, that means that there's just a 1 left, 1z. Okay. And then 18 divided by negative 9 is going to give us negative 2. So we wind up here and then here as one factor. Oh, I'm sorry. Oh, this should be an x. My apologies. This right here, this should be an x. My apologies. That's an x. So we'll change this guy right here to be an x. My apologies. Okay. Still, we got x minus 2 as a factor here. X minus 2. Okay, that's this one and this one. And then what's left is x squared minus 9. Okay. And again, we wind up in the same spot as we did up here, where this is the difference of two squares now. This isn't always going to happen, but you will find that it does happen. X squared and then 9 right here. Okay, this is a 1 as a coefficient, and this is a 9 as a coefficient, or a constant over here. These are both perfect squares. And so we can break this down. Okay. We're going to find two numbers that multiply to give us negative 9 that add to give us 0. There's no middle term here. Well, how about 3 and negative 3? Okay. That means our factors now are x minus 2, which is this one right here. Okay. And then this breaks down into x plus 3, x minus 3. Okay. There you go. Those are the two major ones that you're going to be using to solve polynomials here. There's a third one. It's a little more complex. It's kind of along the lines of completing the square, where if you know what to do, if you know what to look for, then it may make your life a little bit easier and you were able to find some of these solutions more quickly. If you don't know, then it starts to get kind of annoying or really hard to work through. And this is called the factoring using the sum or difference of cubes, right? It depends what's happening here. This one is subtraction, so this was going to be the difference. This one is addition, so this is going to be the sum. And this works only when each of these terms are cubes, okay? Meaning that you can multiply a number by itself 3 times to get there. 1 times 1 times 1 would give us 1, so that's a cube, okay? 5 times 5 times 5 would give us 125. And there are specific forms that we use for these. For this one, right, this out real quick. Okay. That's for this one right here, which is the difference of cubes. And what we do is, so we make two sets of parentheses, and we're going to put the cube root of each term in the first one and keep the sign. Okay. So our first set of parentheses, we're going to take the cube root of 1, and that's 1. Okay, 1x. We're going to take the cube root of 125, which is 5. Okay, and we're going to keep the sign. That's that right there. Okay. And then the second set of parentheses, here and here, give myself some room here. We're going to take the first term and we're going to square it. So 1x times 1x is 1x squared. I'm going to put a 1 there. We don't typically write the 1, but it does exist. Okay. We'll multiply the two terms together, okay, and change the sign. So we're going to multiply 5 times 1, and that's going to be 5, and we're going to change this sign right here. Okay. It was negative right here. Now we're going to change it to positive. And then the last thing we're going to do is we're going to square this number right here. We squared the first one to get here. We're going to square this last one to get here. And so this is going to be plus 25. Okay. And so this is called the difference of cubes. And this doesn't break down anymore. This is as far as we're going to go with how this breaks down. Because we're going to find two numbers that multiply to give us 25 that add to give us 5. And there aren't any. Okay. That's as far as we get to go. We could check our work if we wanted to. If we wanted to multiply all these back out, and I'm going to do it with you this time just to show you why this works. Okay, right here, 1x times 1x squared is 1x to the third. Okay. 1x times 5x is 5x squared. 1x times 25 is 25x. Negative 5 times 1x squared is negative 5x squared. Negative 5 times positive 5x is negative 25x. And then negative 5 times positive 25 is negative 125. When we combine like terms, right, which we did in section 4.2, okay, here and here, they cancel each other out because positive 25x and negative 25x. Positive 5x squared and negative 5x squared go away. And what you're left with is x to the third minus 125. Okay, and that's what we started with right there. All right. And so that one's the sum and the difference of cubes. And so for down here, for this letter B, we're going to start it off with the same. Okay, we're going to do two sets of parentheses. It looks very similar to this one, except we're going to change a sign inside of it. See here, when we started, we kept the sign in this parenthesis. This was negative. We got negative right here. This one's positive. We're going to get the positive right there. Okay, a squared minus ab plus b squared. And that's the difference right there. Now, this is the format always for this right here, okay, which is where we got right here. And this is the format for the sum right here. This is actually our answer right here. Okay, this work right here was just showing you that it did in fact factor down to that. Okay, and so what we're going to do is we're going to take the cube roots of each term and put them out in front. Now the problem here is we got 16s to the fifth and 54s squared. We can't take a cube root of 16 because there's no perfect cube root of 16. There is no perfect cube root of 64. That's because we still have a little bit of cleaning up to do first, because we're always going to try and remove the greatest common factor. There's a greatest common factor in here that we weren't aware of when we initially started. And that is what number goes into 16 and what number also goes into 54. Okay. And that is going to be 2. 2 goes into 16 and 2 goes into 54. Because what we're going to try and do is we're going to try and take out the greatest common factor between both these terms, s squared, because there's 2 here and 5 here. Okay. When we do that, this is a 2s squared, not 25 squared, that's 2s squared. We are left with 8s to the third plus 27. Okay. Now we can factor this thing down. We took out the 2s squared, and now we can take this and factor it down even more. We've got a plus b, so we're going to take the cube root of a and the cube root of b. Okay? Well, the cube root of a is 2s. That's not 25, that's 2s. Okay? And the cube root of b is 3. Cube root of 8 is 2. Cube root of 7 is 27 is 3. And cube root of s to the third is just s. This is a s. This is not a 5. They look the same, so hopefully you're paying attention to that. Okay? And then inside of the parentheses, okay, we're going to square the first term. Well, the first term is 2, so this is going to be 4s squared, because 2s times 2s is 4s squared. Okay? We're going to multiply the two terms together, and that's going to give us negative 6s. Okay? Because we had 2 times 3 is 6s, and then we're going to change the sign, like we did up here. Right? We multiply these two together, a and b, and then we change the sign. Okay? We're going to multiply these two together, and then change the sign, and then take this one and square it, and that gives you 9 like that. Okay? This right here is where we're factored to. Okay? So you can see where this comes in as valuable. You won't use this all the time. You won't even use that most of the time. So the time you're going to focus on using factoring using the greatest common factor and factoring by grouping. But you still need to be exposed to this to know when it happens so that you can be sure to find all the solutions. And that's it. So thank you very much for watching. Please make sure to go back, rewind, look over this. And if you have any questions, make sure you bring it up to us, and we'll help you out as best we can. Thanks. Bye.